Okay, this video is to help you with this really interesting question. So started out with a verbal description, so you could try to draw a picture of a square and a circle centered at opposite corners. So at Q and A, we have two different circles that are centered such that their radius is the same length as the side of the square, which in this case is 12 inches long. So we do know that we've got 12 for all of these sides. And we're trying to find the region, the area of the region of overlap between the two circles. So, perplexing questions, almost like a flower petal, or some students called it sort of an oval-ish shape. Would be a little bit pointed on the ends, but that's not obviously a shape that we know. So we need to split that into shapes that we do know how to find the area of. And that's the whole trick with these problems, is trying to see that shape. What is that shape going to be? So I'm going to start with drawing an extra line in here. So I'm going to connect the opposite corners, and I'm hopefully going to turn this into a familiar problem. So let's start with that line, and then I want you to look at just one half of that. So I'm actually going to try to find, my goal right now is going to be to try to find the area of only this region. And that's probably still looking a little bit complicated, but hopefully we can see that as what is defined in geometry as a segment of a circle. What I like to describe as the crust or the leftover when I take a square and subtract a circle from it. So, or sorry, when I take a sector of a circle and subtract a triangle from it. So what I'm going to do is I'm going to trace that circle. I know this is a crazy amount of circles, isn't it? Take a guess at where the center is, and then let's go ahead and sketch in what we had there. So instead of drawing the whole square, I'm drawing the bottom half of the square. If you can follow along, this is A, this is U, and this is D. And then I'm going to connect and can you see that this is the exact same thing as what I had over on my original picture. Okay, so hopefully you can follow that, and now I'm ready to go ahead and sort of get started with the math part of this. And, ooh, I'm going to use my paper. Okay, we'll just use the bottom space here. So what I want to do to find that is I want to start big, and then I want to work small. So I'm actually going to break this down even more. I obviously took off half the picture. And by the way, the yellow section is going to be the same. So I could redraw that and do kind of the flip of circle, sector, and triangle. And that would be my yellow region. So I'm just going to double my answer once I get it. Okay? So the first thing I'm going to do is take bigger than that. I'm going to actually take this entire sector of the circle, and this is how I presented this in a different video, is I said, okay, let's take the sector of the circle, and then let's subtract the part that I don't want. So the part that I don't want in this case is what I'm highlighting in purple right now, this triangle. So let's subtract that triangle. And that essentially will leave me with leftovers. What I haven't watched. So that's my goal. So the good news is the math isn't too hard here. My triangle is a right triangle because it was a square, so I know it's a right angle. So I'm going to have area of a square, or sorry, I'm going to have sector. Formula is pi r squared times degree measure over 360. That's pi times 12 squared times 90 over 360, which is really just 1/4 of my circle. 12 squared is 144, so 144 pi over 4 happens to be 36 pi when I divide that. And then my triangle, so I'm subtracting the area of the triangle, which is 1/2 base times height. In a right triangle, I can call this the base and that the height. Use the two legs, which are 12 and 12. So 1/2 12 times 12, and that is 144 divided by 2, which is 72. So that would be the area of my orange piece, but remember I needed to double that. So my final answer here is going to be 2 times the quantity, it's all about the parentheses here, guys, 36 pi minus 72. And if you want an actual number for that, you're welcome to type that in your calculator, 36 pi minus 72. It comes out to a decimal. 36 times 3-ish is 108, a little bigger than that. So 110 something divided minus 72. But in exact form, that would be, go ahead and distribute your 2, 72 pi minus 144 units squared would be my final answer. Okay, hopefully that helps you to think through this question. Extension would be, what if there are more petals in your flower, so to speak? And there can be some interesting questions. Let's see if I can find one. Just to give you a couple visual challenges would be something like this or that. Cool? Okay, have fun playing with geometry.